All right, guys, we are now on our next unit, and it is equivalent fractions again, but it's actually our easiest equivalent fractions that we're going to be doing, believe it or not. This is how your parents do it. This is how I do it. This is how you'll do it when you get to college, when you get to 6th grade. If you can master this, you're going to have no problem. And so what we're going to be doing is we have the same. Whatever we do to the numerator, we have to do to the denominator. So whatever we multiply the top number by, we have to multiply the bottom number by. So it's going to look kind of like a fraction like this. And notice the top number is the same as the bottom number. Numerator is the same as the bottom. And why we're doing that is, maybe you've noticed, that's the same as 1. And remember, whenever we multiply a number by 1, it's always going to be the same number. So if we multiply it by 3/3, that's also 1. If we multiply it by 44/44, that's also 1. So when we're multiplying, we're not changing our number at all. It's really just staying the same. It's just going to look a little different. So we're going to jump on in, and you're going to see how this works. So we have question number 1, and it says, use an area model of multiplication to show why 5/6 and 10/12 are equivalent fractions. So we're going to draw our model, and remember, we can just split it in half and count those pieces up that are shaded now and count our total, and we'll see that's 10/12. So we just need to make that model. We just need to draw it. So I'm going to draw my box. I'm going to split it up into 6 pieces, and then I'm going to shade 5 of them in. So I need to erase this because I've made my box a little too big. So let's shade 5 of them in blue. And now I'm going to split it in half. And that's going to show me my 10/12. So let me erase that and just use a regular one instead of the highlighter. So perfect. Split up, and now you can count there's 10 blue pieces and 12 total pieces. That's my 10/12. Now, I'm not done. Why am I not done? Well, it says I need to use multiplication. So let's throw that in here. So 5/6, and we need to think, how do we get to 10/12? What did we multiply it by? Well, we multiplied it by 2, because 5 times 2 equals 10, and 6 times 2 equals 12. So remember, whatever we do to the numerator, we have to do to the denominator. Notice how that 2 is the same for the top and the bottom. Remember, when we multiply fractions, we just multiply straight across. So 5 times 2 is 10, 6 times 2 is 12. So that's how we show it the multiplication. So on to number 2. It says, use multiplication to explain why 3/4 and 8/12 are not equivalent fractions. Now notice it does say explain, but we're going to show with math first so we understand what's going on. So we have 3/4 and we're showing how it's not equal to 8/12. So I'm going to put a question mark because we're not sure about it. Now remember our saying, whatever we do to the denominator, we have to do to the numerator. So how do we get from 4 to 12? We multiply by 3. So that means we have to multiply the top by 3. So let's think about that. Is 3 times 3 equal to 8? No, it's equal to 9. So that's telling me right there they're not equivalent fractions. So I need to now take that math that we just did and show in a sentence why they're not equivalent. And they're not equivalent because we can't multiply that numerator and denominator by 3. So this is my sentence that we're going to write. You cannot multiply the numerator. I'm going to put a capital N there because that's our important vocabulary word. Numerator is that top number in a fraction, and denominator. And I capitalize denominator because that's an important vocabulary word. It's that bottom number of the fraction. It tells us the total pieces that we need. So you cannot multiply the numerator and denominator of 3/4 by the same number to get 8/12. All right. So now let's head to number 3. So just more of the practice with just the numbers until we get better at it. So here it's nice to give us a model, and it's showing us that 1/4 is the same as 4/2. And they just split it in half right there. So this one we actually don't even multiply, even though it says to. So let's just check, and I see there's 2 shaded parts, so it looks like we're multiplying it by 2, which means whatever we do to the numerator, we have to do to the denominator. So we have to multiply that bottom number by 2. So 2 times 2 equals 4. And hey, that makes sense because I see 2 of those shaded pieces in right there, and I see 4 total pieces as well. 1, 2. 3, 4. So I need 4 to make that whole. So yeah, it looks like it matches. But notice it takes a lot longer to solve these with the area model. So we're going to practice on just the math portion of multiplying. So let's think, how do we get from 4 to 12? Well, we multiplied by 3. And then we have our saying, whatever we do to the denominator, we have to do to the numerator. So I need to multiply that by 3 as well. 3 times what? Well, since I multiply the bottom number by 3, I need to multiply the top number by 3. So 3 times 3 equals 9. So now let's head to number 5. So we have that same thing, whatever we do to the numerator, we have to do to the denominator. So how do I get from 5 to 10? Well, I multiplied by 2. So whatever I do to the top, I have to do to the bottom. So what number did I multiply the top by? I multiplied it by 2. So what do I have to multiply the bottom by? By 2. So 5 times 2 equals 10. And hey, 5 fifths equals 1 whole, 10 tenths equals 1 whole. And so I'm pretty sure that my answer is correct because 1 whole is the same as 1 whole. So now our same thing, how did I get from 3 to 6? What did I multiply it by? Well, it looks like I multiplied it by 2. And we have this saying that we're going to hear over and over and over again. Whatever you do to the numerator, you have to do to the denominator. So what do I have to multiply the denominator by? I multiplied it by 2 on top, so I need to multiply it by 2 on the bottom. Now 2 times 2 equals 4. So now we have this next one. Same thing. How did I get from 6 to 12? Well, I multiplied it by 2. And we have our saying again, whatever I do to the denominator, I have to do to the numerator. So what do I have to multiply it by? I need to multiply it by 2. So we have 1 times 2 equals 2. Now we're going to go to number 8 to 13. And this one you'll notice there's more steps for us to fill in. We have to write what goes in those boxes, what we're multiplying it by. So our first couple, they give us a model. So we can look and we can see our answer is actually 4 twelfths. I'm sorry, 4 sixths. But how we can do that with math also is we multiply our numerators across. 2 times 2 equals 4, 3 times 2 equals 6. You'll notice that matches that model we had. You just multiply straight across. So the same thing with this one. 3 6 times 2 halves. We multiply our numerators straight across. 3 times 2 equals 6. And we multiply the denominator straight across. 6 times 2 equals 12. And you'll notice it matches that model right there. Now these ones are faster because we don't have those models with us, and we should get kind of the hang of it by now. So we need to think, how do we get from 5 to 10? What did we multiply it by? Well, we multiplied it by 2. And we have our saying, whatever we do to the denominator, we have to do to the numerator. So we have to multiply the top number by 2 also. 1 times 2 equals 2. Now this is why it's important. We always tell you to know your multiplication facts because it's going to make this so much faster. Now this one's a big number. How do we get from 4 to 100? Well, I don't know my 4's facts all the way up to 100, but I do know of quarters. So if I think of quarters in dollars, I know 4 quarters equals $1. So that's like 4 times 25 because 25 is a quarter. So I'm probably multiplying by 25. And then we have our saying, whatever we do to the bottom, we have to do to the top. So we're multiplying that by 25 too. Now if I don't know 5 times 25, I have this strategy I can use. I know 4 25s is 100, and 5 25s is just one more group of 25. So I just add 100 plus 25, and I get 125. Now here's our next one. How do we get from 4 to 12? Again, if we don't know our multiplication facts, it's going to be more difficult. But I do, and I know it's 3. 4 times 3 equals 12. And we have our saying, whatever we do to the bottom, we have to do to the top, so we need to multiply it by 3 also. 7 times 3 equals 21. So let's head to our next one. How did I get from 3 to 9? What did I multiply it by? I believe it's 3. So whatever we do to the top, we have to do to the bottom. Whatever we do to the numerator, we have to do to the denominator. So we need to multiply that by 3 also. 4 times 3 equals 12. Again, this is why we need to know our multiplication facts. It will go so much faster. Now 14 starts with some different directions. It says write 2 equivalent fractions for each given. So it doesn't tell us what numbers we need to multiply by, so we get to pick. So I'm going to just start with 2 halves, 2 over 2, because that's pretty easy. I should know my 2's facts. So 1 times 2 is 2, 10 times 2 is 20. And then we need to find another equivalent fraction, because it said list 2 of them. So I'm just going to pick 5 fifths. So 1 times 5 is 5, And then we multiply the two bottom numbers. 10 times 5 is 50. And these are my equivalent fractions. Those are my two equivalent fractions to 1/10, 2/20ths, and 5/5. Now for this one, again, they didn't tell us what to multiply by, so I'm just going to pick 3/3. So remember, as long as it's the same number for the top and the bottom, I can pick any numbers I want. So 4 times 3, what does that equal? 12. And then I multiply my denominators. 2 times 3 equals 6. And now let's head to our next one. 4 times 2, or 4 halves times, I'm going to pick 10/10, which is 40/20ths. Remember, you can pick any number you want as long as the number is the same for the top and the bottom. As long as you're multiplying by the same numerator and denominator number. So 4 halves is the same as 12, 6 is the same as 40/20ths. Now, since they didn't tell us, I probably want to pick easy numbers each time. So I'm going to keep focusing on just multiplying by 2 halves. So 5/6 times 2 halves is 10/12. And then I'm going to pick another easy one. I know my 3's pretty well, so I'm going to multiply by 3/3. So 5/6 times 3/3 is 15/18. So now let's head, oops, number 17. I almost forgot that guy. So I'm going to multiply by 2 halves again. And then I'm also going to multiply by 3/3, just because those are easy numbers to work with. So 1 times 2 is 2, 3 times 2 is 6. And our next one, 1 times 3 is 3, and the denominator is 3 times 3 is 9. So those are my equivalent fractions right there. So now let's head to number 18. So number 18, again, I'm going to multiply by 2 halves. 2 times 2 is 4, 5 times 2 is 10. And then I'm going to do the same thing, and I'm going to multiply it by 3/3 this time. Oh no, I'll do a different one so you can see. I can pick any number as long as the numerator and denominator are the same. So I'll do 7s. So 2 times 7 is 14. 5 times 7 is 35. And oh, my iPad jumped. So those are my equivalent fractions right there. So 3/3, or 3/4, I'm going to go back and multiply it by 2 halves again, just because those 2's are easy. Remember, I multiply the numerators together, multiply the denominators together. 3 times 2 is 6, 4 times 2 is 8. And now my next one, I'm going to multiply by 3/3. 3 times 3 is 9, 4 times 3 is 12. So again, these are my equivalent fractions. As long as I multiply the numerator and denominator by the same numbers, I'm okay. Now we have our 9 halves. So again, I'm going to do 2 halves. 9 times 2 is 18. 2 times 2 is 4. And now we're going to do 9 halves times 3/3. So 9 times 3 is 27. And 2 times 3 is 6. So those are my equivalent fractions. Now this one's a little different because I don't know my 12's facts very well or my 7's facts, but I can multiply by 2 well. 2 times 7 is 14. 12 times 2 is 24. But I don't know my 3's facts with 12's very well, so I'm going to multiply by 10/10, because remember, it's really easy to multiply by 10. I just add a 0 on. So 7 times 10 is 70. 12 times 10 is 120. And those are my equivalent fractions. So now let's head to the back page with our harder word problems. But we got this because we've been doing it well. Now it says, use the table at the right to solve the next 2 problems. So it looks like our tables talk about vegetables and gardens. So number 22 says this. It says, write 3 equivalent fractions to describe the portion of the garden plan with carrots. And when I look, I see carrots is 1/6 of the garden. So it's telling me I need 3 fractions that are equivalent to 1/6. So I can again multiply it by any number I want as long as it's the same for the numerator and denominator. So I'm going to do 2 halves. 1 times 2 is 2. 6 times 2 is 12. So these are equivalent fractions. So I have 1 equivalent fraction, but I need 3. So I need to multiply 1/6 by another number. So I'm going to do 3/3. So 1 times 3 is 3. 6 times 3 is 18. So now I have 2 equivalent fractions, but I'm still going to need a 4th one, or a 3rd one. So I'm going to follow my pattern. I multiplied by 2 halves, 3/3. I'm going to do 4/4, just the next number in our series. So we have 1 times 4 is 4, and we have our denominator, 6 times 4 is 24. So now I have 3 equivalent fractions for 1/6. So I'm going to head to number 23 now. So number 23 says what? It says, which vegetable takes up the same amount of the garden as the tomatoes? Well, tomatoes take up 1/4. So we need to find the equivalent fraction to 1/4. I know it's probably not going to be carrots because I already used them, and I don't see 1/6 and 1/4 when I made those equivalent fractions. So when I find my answer, I'm going to need to explain it. So I'm going to start with peppers, and I'm going to check and see if 1/4 is the same as 4/12. So I put that question mark underneath because I'm not sure if they are. So now I'm going to think, how did I get from 1 to 4? Well, I multiplied by 4. So now I'm also going to think, whatever I do to the top, I have to do the bottom. So I have to multiply it by 4 also. Is 4 times 4 equal to 12? No, it's equal to 16. So that's telling me that this isn't a true math sentence, which means they're not equivalent. So it's not peppers. So let's check beans. Now, if it's not beans, then we're in trouble because we're kind of out of numbers to work with. So let's zoom in. 1 to 3, we multiplied by 3. So whatever we do to the numerator, we have to do to the denominator. So we have to multiply it by 3. 4 times 3 is 12. That is correct. So those are equivalent fractions. 1/4 and 3/12. So now I need to explain. We're not just done. So we're just telling them that beans take up the same amount of space. So beans take up the same amount of space. Oh, and oops, I made a mistake. I forgot to put amount in. So I'm going to put the little caret there and insert the word amount. Beans take up the same amount of space. And then I'm going to switch to blue because this is our explanation on how we know they're equivalent. So 1/4 and 3/12 are equivalent. I remember my base word in equivalent is equal. So we're saying these fractions are equal. 1/4 and 3/12 are equivalent fractions because you can multiply. And what did we multiply? Remember, we multiplied the numerator and denominator. It's always the numerator and denominator because you can multiply the numerator and denominator. And what fraction do we multiply it by? Well, we multiplied 1/4, so you can multiply the numerator and denominator of 1/4, and we multiplied it by 3/3. And what did we get? We got 3/12. So our sentence, beans take up the same amount of space. 1/4 and 3/12 are equivalent fractions because you can multiply the numerator and denominator of 1/4 by 3/3 and get our 3/12. So now number 24. Gina has 5 packets of seeds. Each packet has 12 seeds. Gina wants to divide the seeds evenly among 10 flower pots. Now I see that word divide, so we're probably going to do some kind of division in this problem. Then it says how many seeds can she plant in each flower pot? So what do we need to do? First we need to find our total number of seeds. And it's telling me there's packets. So I'm going to draw a model that's going to show us 5 packets, 5 containers. So here's my 5 containers, and each packet has 12 seeds in it. So what does this look like? It looks like 12 plus 12 plus 12 plus 12, which is repeat addition, which is multiplication. So I'm going to do 5 groups of 12. 5 times 12. 5 times 2 is 10. Regroup the 1. 5 times 1 is 5, plus 1 is 6. So how many seeds are there? There's 60 seeds total. So now Gina's going to take those 60 seeds. She's going to divide them among those 10 flower pots. So we have 60 divided by 10. I don't know my division that well, but thankfully I know they're inverses with multiplication. So I can think 10 times what equals 60? 10 times 6 equals 60. So I can check using my does McDonald's sell cheeseburgers. I multiply, subtract. I see there was no remainder, so I see it is 6. So how many seeds are going to go in each pot? There's going to be 6 seeds in each pot. So now number 25. Jenny said, I'm thinking of a fraction that is equivalent to 2/6. So I'm going to write 2/6 down. The numerator is 8 less than the denominator. What fraction is Jenny thinking of? Well, there's a lot of stuff going on in that sentence. The numerator is 8 less than the denominator. So I'm going to color code this so I can keep track of my numerator and denominator. So remember, my numerator is that top number. So equivalent fraction, the top number is going to be 8 less than the denominator. So it's going to be 8 less than this bottom number. So whatever that bottom number is, if I take away 8 from it, I should get the red number up top. Now, I'll tell you, I have no idea where to start. But I do know whatever that bottom number is, I need to take away 8 and it will give me that red number. So I can just start with the number 9 and put it take away 8 and then see that's 1 and do like 1/9. But that's not going to be equivalent fraction. So what I'm going to do is I'm just going to make a list of equivalent fractions and see if it matches my setup. So I'm going to do it by 2 halves. So 2/6 times 2 halves is 4/12. So I put the 4/12 in. And hey, look, what would 12 take away 8 equal? That's going to equal 4, which is the number we have up top. So that's our equivalent fraction. That's the fraction Jenny's thinking of. So we just lucked into it by making our table, making our chart, and the first number we checked was it. So now let's head to number 26. 26, there's two ways to solve this. So we're going to solve one way with the 2/3 fraction and one way with the 1/4. It says use the fractions from the box once to complete the tables. So we need to find fractions that are equivalent to 2/3. So I'm just going to start by multiplying it by 2 halves and see if that matches one of my numbers up there. 2 times 2 is 4, 3 times 2 is 6, which is 4, 6, which is up there. So I got one of them down. Now I've done 2 halves, so what comes after 2 halves I can multiply by? Well, 3/3. Remember, that's the same as 1, so I'm really not changing number. And do I see that? 2 times 3 is 6, 3 times 3 is 9. I don't see 6/9 up there. So let's go to our next one. What comes after 3/3? Well, 4/4. So let's multiply by 4/4 and see if that pops up. So 2 times 4 is 8, and 3 times 4 is 12, and look, that number's right there. So 8/12 is also equivalent. Now, I do think I'm done with it because there's 2 boxes. I've filled both of those 2 boxes in. So let's go to our other one, 1/4. This one we're going to solve differently, so we have our other strategy. We have 2 numbers left, so we're going to pretend they're equal to each other and see if we can multiply the numerator and denominator by the same number. So how to get from 1 to 2? Well, I multiply it by 2, and whatever I do to the top, I have to do the bottom. 4 times 2 is 8. It's a true number sentence, so that's an equivalent fraction. So now let's erase it, and we're going to check it with our last one, that 3/12. So how do we get from 1 to 3? We multiply it by 3. And so now if it's an equivalent fraction, we should multiply the denominator by 3. So 4 times 3 equals 12, which it does. So hey, that's our other equivalent fraction. Pretty easy. Again, this is why we need to know our multiplication facts. Number 27, our last one, says use each of the numbers from the box once to complete the equations. Now, there's a lot of numbers there. I can just randomly guess, but I'm going to do what I've done in the past 2 problems. It's helped me well. I'm just going to multiply it by 2 and see if those numbers appear. So 1/2 times 2 halves, 1 times 2 is 2, 2 times 2 is 4, and look, both those numbers are up there. So we're off to a good start. So now let's head to our next one. I'm going to switch colors. I'm going to multiply it by 2 halves again. So 2 for the numerator, 2 for the denominator. 5 times 2 is 10, 6 times 2 is 12. Those numbers, oh man, it just keeps jumping. Those 2 numbers are both on my word bank or number bank, so we're good. So hopefully 6 and 8 will be my last 2. So again, I'm going to switch colors. I'm going to multiply it by 2 over 2, 2 halves. 3 times 2 is 6, and 4 times 2 is 8. Voila! Those are my last 2. So remember, it's not that hard as long as you remember, whatever you multiply the numerator by, you need to multiply the denominator by. Good luck, guys. You got this.